Is it? Oh, we're recording. All right, we're recording. So what we're going to do in this recording here, we're going to learn lesson 1.4, and we're just going to practice a little bit about solving and graphing inequalities. This is new, or this is review. Being that you're Algebra 2 students, you have already solved equations, and you have solved inequalities. This is not new to you. You have already graphed them. And you also know how to solve and write compound inequalities. So this is just a short practice today to review previously learned objectives. Just making sure. Flip over to... When you look at these properties are continued to help. This was true in equations, and it's true in inequalities. If A is less than B, and B is less than C, then A must be less than C. That's there's additive. If A is less than B and you can add C to both sides and it'll still be true. I should be saying less than or equal to. If A is less than or equal to B, you can subtract from both sides the same value of C and it'll still be true. You can multiply with the multiplication property. You can multiply C to both sides, it'll still be true. You can divide both sides by C, it'll still be true. This shows that whole thing. If you're solving equations or inequalities, as long as you do the same thing to both sides, you're good, right, guys? So yeah, I'm dang good. Down here at the bottom, briefly talks about compound inequalities. Is a pair of inequalities joined by and or. So it could be like this one. -1 is less than x, and x is less than or equal to 3, which can be written together, that compound inequality where x is fitting neatly in between -1 and 3. Let's practice graphing that. If this was your solution where x falls less than or equal to 3, but x could be seen as greater than -1. If I was to graph that, this is, when I graph these, and this is what we'll be doing today, I only grab the number line that I need. So I need a number line that's, we'll call this -1. And so we'll go 0, 1, 2, 3. That's all I need. I just need these values. And then it comes down to remembering when it's an open circle and closed circle, and that'll be on your practice questions. That'll be on your test. You know, just graphing these appropriately. Which one of those would be an open circle, the -1 or the 3? Yep, right here we say that signifies the solutions do not include -1, but come right up to it. And x is on x. If you were to turn this around, you could read that as x greater than -1, can't you? -1 less than x is the same thing as x greater than -1. Y'all agree? We can flip that. So that means I would shade this way, all the way up into where? 3. And that 3 we have a closed circle, correct? Because the equal to bar underneath that says the solutions can include 3, all the way up to 3 and include 3. How many of y'all go, oh, I know that. I know that. I walked into your classroom this year, Mr. Bush, knowing that. That's good. That just confirms what you already know. Then the other option over here is on a compound, is it can say x is less than -1 or x is greater than or equal to 3. Would that be graphed the same as this one? How do you think the graph of this solution, or solutions, would be different than this one? Dang right, baby. Oh, yeah. Front row with the answer. It's still focusing on an open circle at -1, still focusing on a closed circle at 3, but this time the solutions for x are less than, so yep. If we draw yourself another number line, we still focus at -1. We still go over here 0, 1, 2, 3. Still have an open circle -1. We'll still have a closed circle at 3. That says x is less than -1. So like you said so amazingly, we'd shade out. What an arrow. What an arrow. To the left, to the less than side of -1, and to the greater than side of 3. So close circle, then shade that way. So our solutions are either side. So that's examples of compound inequality. All right, turn the page, get to your first blank side right here. We'll do a couple of these together. That way you don't have to do them later. So write them nice and neat, show your work. Now, I will tell you, calculators can still be good for calculating. Calculators, we learned, can solve equations. Calculators only solve inequalities with a certain kind of calculator. This one doesn't solve the inequality. You can graph the inequality, but you can't solve it. Everybody agree? So for this short amount of time, I could put the equation in. You know, I could numerically solve it, but I'd have to replace any inequality with an equal sign and solve it like it's an equation. And that involves some more steps. So for right now, we only got a little bit of these. We're just going to practice it on paper. So just a basic inequality. Just like you've seen before, we're going to solve this thing like you've solved everything else. What's the first thing in solving? Anybody? Yeah, we can subtract 16 from both sides of an inequality. It'll still be true. What you notice, the one thing we're going to see here is when we divide both sides by this -4, this is one thing that is different with inequalities versus equations. If you divide or multiply both sides by a negative, I have to remember to do one thing. Yes, sir. Yes, sir. So this is now becomes, instead of less than or equal to, is now greater than or equal to -5. And then we graph it by drawing that number line. And all I'm going to focus on, I'm going to get my -5, put -6 on this side, put -4 on that side. I usually only have 3 numbers on my number lines. That's all I need to know what I'm doing. Hopefully you know the farther left you go is the smaller, the farther right on the number line, the bigger. So t is greater than or equal to -5. That's a closed circle at -5. Shaded which direction, right or left? Right. Go this way, darken this side, put an arrow. Say the solutions are on the greater than side. So this first one just gives you the indication of remembering to switch your inequality. Here's another example, number 9. It's a inequality with an unknown on both sides, so it's a very complex inequality. Still solve it like it was an equation. There's nothing I can do on the left side. On the right side, I could use the distributive property, so let's go 10 minus x greater than or equal to -6 minus 2x. I don't flip the inequality there. I didn't multiply a negative to both sides, did I? I just multiply the -2 over here using the distributive property. So that doesn't flip my inequality yet. Okay. And now I just want to decide where am I going to put my unknown and where will I put the rest of everything. So I'm going to bring the 2x over here. So add the 2x. Leaves us with 10 plus x greater than or equal to that -6. -1 plus 2 is 2. Excuse me, -1 plus 2 is 1x. Subtract the 10. X would be greater than or equal to, what's that, -16? Did I mess anything up? Does it look all right? Draw a line to graph. So I'm going to have my negative 16. Over here would be negative 17. Over here would be negative 15. So on that number line, it's a closed circle at negative 16, shaded right again to the greater than side. That wasn't very good at showing you which side was darker. Maybe that'll help. There we go. Solutions. Now, my arrow stopped right there, but that doesn't mean the solution stopped there. It goes forever that way. Anything greater than or equal to negative 16. So, hey, guys, on this, you're going to have some like that. If you practice them, and then if you're struggling, ask me or practice it again. These would be very doable. The next kind you'll have are the compound kind. So let's look at this right here. So number 10, negative 9, less than or equal to 4x plus 3, less than or equal to 11. So this is called a compound inequality. And the trick is you solve both sides. But y'all probably have seen that before. I got to solve this inequality. So it's imagine like this. Imagine that what I've covered up with my finger is not even there. I got to solve this first less than or equal to side. And if I was to cover this up, I would solve this side. So I can subtract 3 here, here, and here. What does that give me? That gives me negative 12 less than or equal to 4x less than or equal to 8. Am I doing that right? No. And then I'd have to solve over here and over here. So if I divide a 4 to this side and this side, everything's got a 4 being divided. I would have negative 3 less than or equal to x less than or equal to 2. So that solution for x, after you simplify that middle part, shows us the solutions are from negative 3 to 2. You would draw a line. I need a negative 3, a negative 2, negative 1, 0, 1, 2. There we go. Are the solutions in between negative 3 and 2 or outside of negative 3 and 2? What do y'all think? In between or outside? Yeah, I like that. They're in between, yes. Negative 3 to 2 are both closed circle because we have the equal to bar. And you would shade in between. Okay, I'm going to give you a practice paper that has more of these. You're not going to do a ton, but you're going to do some of these to practice. And then you can ask me questions as you're going if you get stumped, and then we can look at them together at the end, okay? Sound good?